All right, so we're now recording. Well, thanks everybody for joining us for the February edition of the gRPC community meeting. We got a great presentation for you today. And I also wanted to call out, for those of you who I haven't met yet, I'm April. We have a big week coming, or a big day coming this week on Friday. Does anyone know what happens on Friday? Why it's a special day?
Is it a birthday?
It is a birthday. It's
right.
gRPC's birthday. So gRPC will be 6 on Friday. So a feisty little toddler. Or I don't know, the open source project years are probably like dog years. But yeah, so keep an eye on our Twitter account Friday because we might have some fun stuff planned. So that's just a little, heads up for some fun celebration. And yeah, thanks for being part of the community and being supporters and users and contributors to gRPC over the past 6 years. So we appreciate all of it. Thank you.
Still waiting on the cakes to be delivered at home, right?
I know. Yeah, if we were back in the office, we could have a cake, but unfortunately, you're on your own for cake this year. I think when we all can be around each other again, we'll just have cake every day for whatever reason. Will be worthy of celebration.
It's also harder to get dogs this way.
Well, awesome. So,
to pet a dog.
Oh, go ahead. Sorry.
It's also harder to get everyone to get puppies for everyone to pet this way.
That's true. We have our beloved Pancakes. Actually, he made his debut 2 years ago for the birthday. That was our belated birthday present to gRPC. But yeah, so Pancakes will be helping us Friday celebrate as well. So yeah. Well, I want to hand it over to Ahmet for presentation, and then we've got a lot of the core maintainers here on the call, and so hopefully we can do some Q&A afterwards, and you can bring all your tough questions for them, and I'm sure Ahmet will be able to answer questions around his presentation as well. So without any further ado, Ahmet, the floor is yours.
Okay, thanks, April. I will share my screen now. All right. Okay. All right, so I assume you can see my screen now. Quick thumbs up, please. Are you able to see my screen? All right, perfect. So my name is Ahmet Alp Balkan. I'm not a frequent member attending this community, but I'm a gRPC user myself. I always try to advocate inside Google for other people to use gRPC. I'm personally a developer advocate at Google, working on specifically Cloud Run, but in the past I actually worked on Kubernetes a fair amount. So one of the contributions that I actually have to gRPC project is the gRPC Health project. Maybe you've heard of this project or maybe used it. I think this has reached 3 million downloads this year. It means 3 million people, 3 million times at least we helped people health check their gRPC servers. So this is my little contribution to the gRPC project. So today I want to talk to you about Cloud Run. If you never heard of that, that's totally fine. And I'll do my best to not turn this into a sales pitch. My intention is definitely not that. And we'll be talking about some open source technologies maybe that you've never heard of before. So I'll just jump right in. I want to do an early demo so that you don't get bored. So this talk is going to be sort of like a technical overview about Cloud Run and how is it related to gRPC. So Cloud Run in a nutshell is a serverless containers platform on Google's managed infrastructures. If you hate containers, please do not disconnect. I'll find a way to keep you hooked onto the presentation. But basically today what we're going to do is, you all know the route guide example, right? We all probably learned, unless you're one of the core maintainers, you probably learned gRPC through the route guide example. So we'll take the route guide example in actually different languages, and I'll show you how to turn the route guide examples into container images and run them effortlessly with TLS and everything on Google's infrastructure. So I'm actually going to exit the slides right here. So I'm going to go to the route guide example that I have here. So right in this directory, I have the the classic route guide example with the client and the server. So the first thing I'm going to do, I'm going to go into the server directory. if you take a look at what I changed in this directory, I basically just, if you know Go, by the way, if you don't know Go, we'll get there. Don't also please do not disconnect. So what I did in this directory was I basically created a Go module, which basically is called root guide and the usual dependencies that we have here. And I made a very small change in the server, which I think I added a sleep here so that we can see something much easier. And then I changed this localhost to listen on all the port numbers. But that was basically it. So right now, I'm going to show you, again, in this directory, there is no Docker file. If you know containers, you need something like Docker file usually to build containers. But I'll first talk about a project that we have developed so that you can turn your Go programs into container images very easily. So that tool is called Co. You can find this at github.com/google/co. Co is a tool for building Go programs into container images in a very easy way. So what I will do here is, again, I don't know anything about Docker, let's say, all right? I have a function, I have a program here with a main function. So all I need to do is I will say, this is where I would like to push my container image. You can put here anything like Docker Hub or any other container registry. It doesn't really matter. So at this point, all I need to do is, well, actually, I will check the server really quickly because I forgot which port number that we listen on. I think it was like 10,000, so I'll go with that. So what I will do here is I will deploy this application to Cloud Run. And to do that, all I need to do is gcloud run deploy. And I'll call this route guide. I'll say, please build me an image and put its name right here. And I'll say this application runs on port 10,000. And I'll say, let's allow everyone to connect to this image. Like, I do not require any authentication. So what's happening right now is I'm building a container image, and that's what I did here. And I push the container image. Again, take note that I'm not using Docker here at all. I have a Docker running on my machine right now, but I can actually turn that off. It doesn't matter in this case. But before I could even finish my sentence, this gRPC application that you all know is actually available on the internet right now. And it has this TLS endpoint. So let's try to talk to that. I think the way to do that is I have a client here. Let's go to the client directory. Actually, let me go out here. That's much easier. Go run. I'm trying to remember. Yeah, so basically, the sample application comes with a client. And this client basically says, hey, this is my host name, this domain name +443 indicating TLS. And I'm providing the -TLS argument here. And then as you can see, this is a sample application running on Cloud Run. So if you notice that, what happened, that last bit, the messages started to come one by one. And that's mostly because Cloud Run actually supports gRPC in a very nice way. It supports bidirectional streaming, service streaming, client streaming, and the normal unary RPCs. So this is basically Cloud Run in a nutshell. So I would like to switch gears. And actually, I would like to use a Python server. So for that, I'm going to go to the Python example and Python root guide example again. So the only change, if I recall correctly, what I did here was I changed two files. Actually, I added two files into this directory. One of them is the requirements.txt. As you all know, this is how I declare I have gRPC libraries that I use in my server. I actually don't know why there is no requirements.txt here by default, but it's there. So the second thing that I will require is, maybe you know this, maybe not. If you use Heroku before, there's this notion called proc_file, which basically says, this is how you run this application, right? So here I will use something rather interesting. I'm not going to write a Docker file again. I'll introduce you another concept, and that is, I will do this. gcloud beta run deploy. I'll say this is my source directory. This is where my source code is. And then again, I'll say allow unauthenticated. And then I think the port number was something like this. Actually, I'm not going to trust myself. I'm going to check this. All right, 50051. Yeah, I think that was right. What was the error there? I didn't catch that. Yep, I had a typo in one of the arguments. So again, what I'm doing right now is I'm deploying write guide sample that was in Python. Remember, a moment ago, I just deployed it using Go, using this tool called Co, right? So I'm not using Co here, but I'm not writing Docker files either. So what comes into picture here, again, if you use Heroku before, you're familiar with this concept, is called Buildpacks. And Buildpacks is also, as you know, it's part of CNCF. It's called Cloud Native Buildpacks. It has its own website, et cetera, et cetera. So what I'm using here is Google's own Buildpacks, again, an extension of the Buildpacks project, which basically we have our own list of supported runtimes. If you write your application in one of these languages, and we're adding more languages as we go, you can turn them into a container image and deploy to a platform like Cloud Run without any effort. So as you said, I didn't even change any code. I just added 2 files, like I think 3 lines total. And right now, what's going on behind the scenes is that I'm building this container image. Actually, we can go and see what's going on. So I'll go to the link that is building this container image. So what happened here was that I packaged my source code into a zip file by running this command, and I sent it to a remote build farm running on Google Cloud. So as you can see here, a lot of stuff is happening behind the scenes. It's kind of boring, but basically here we're running this thing called Buildpacks. And Buildpacks is realizing, hey, you know what? You have some dependencies. Well, first of all, Buildpacks realizes that this is a Python application. And it goes ahead and installs a bunch of Python dependencies because I have requirements.txt in there, right? So as you can see, this build is successful. But if I go here, now I'm deploying the application. If I recall correctly, what's going to happen in a moment or so, this application will be deployed. But again, the logic is the same. I'll be deploying another gRPC application written in a different language to Cloud Run. So I think this is a good point to stop. And again, as you can see, like the deployment makes progress. And again, in a few seconds, we will have another deployment. Actually, let's wait for that and see how that goes. If it keeps going for another 10 seconds, I think I will actually stop and go to the presentation. All right, assigning traffic to the latest targets. Actually, this is a good time to show you what's happening behind the scenes. So I'll do that. So this is the Cloud Run console. Actually, let me go there manually. All right. Yeah, so as you can see, the application is actually deployed. So if I click on this Route Guide service that I have on Cloud Run, as you can see, I have actually a URL that that has TLS. Simply, you can also bring your own custom domains, and you will also get TLS certificates for those. So another interesting notion that we have here is we have something called revisions. So if I wanted to actually split traffic between the Python-based version and the Go-based version, I can actually do that. I can say I send 50% of the traffic here and another 50 here, and I'll just clear that. So I can basically do stuff like this here. And that lets me do Canary deployments. So again, just to show you, I will go back and run the same client with the same host name again. I think that will also work. Yeah. As you can see, so we're getting a different implementation here because Python has a rather different data set. But again, the same client is able to invoke the Python service. So this is all the gRPC you know. What I did here was I basically almost effortlessly packaged a gRPC server written in different languages using a bunch of open source tools. I don't have to know containers. So this is like something that I encounter quite a bit. People don't want to learn containers, and that's totally fine. You can still make use of serverless platforms without using containers, and that's the beauty of Cloud Run. So let's quickly, I'll give you a few things that I think that you can know about Cloud Run, and they'll be useful. So we talked about what Cloud Run is. Cloud Run, in a nutshell, can run pretty much any Linux executable. As long as you can put it in a container, we're able to run it. It currently does not have any Windows or ARM support. Cloud Run is designed for stateless applications and event processing that are, we basically want you to have a server supporting HTTP, and that includes gRPC, as you know. So that's great for microservices, APIs, and front ends, but it's not really for running game servers or developing your own custom binary protocols, because we need to actually understand what is a request in Cloud Run. So something, again, that people have trouble understanding with Cloud Run is we actually allocate you a CPU only while your container is processing requests. And you actually pay only during this time. If there is no requests, you're not paying on Cloud Run. And that actually makes it quite, economically more efficient. So in this case, we give you some amount of CPU. That actually, if you say, I want 2 CPUs, we'll give you 2 CPUs while there's a request for your container. But this basically means that we don't support background threads. If you have background computation running in the background, that's not for Cloud Run, essentially. I don't want to get stuck on container lifecycle too much, but we basically keep adding new containers to your service if there is more requests. And I'll explain how do we make that decision. But at the end of the day, this is, again, a container. It has a startup, and we send you a termination signal when we want to clean up this container. This is probably the part that is relevant to this meetup. We support gRPC, and very recently, about a month ago, we added full support for gRPC. We actually do support bidirectional streams. That was pretty much the only part missing. I'll talk about that. You can't really develop your own non-HTTP protocols, but WebSockets also work similarly. So one thing about TLS is, usually people find that it's hard to create your own PKI and set up your certificates. We do that for you. If you just notice that I took an application that didn't have any server certificate, but I was able to call it with a server certificate that was provisioned by Google. I was able to verify the authenticity of the server because Google creates a certificate and configures it for my application. And similarly, we actually force this TLS. We don't let you actually make unencrypted calls at all. So the load balancing, there's nothing interesting there. We actually already have automatic load balancing built into Cloud Run. If you want stuff like CDN, we actually offer an experience to go create a custom load balancer. So this is the part that it kind of gets tricky. So Cloud Run lets you actually limit how many requests you're able to handle in an application. For example, if you say that my application cannot handle more than 10 requests at the same time, you can just see a box that says concurrency, and you could just type 10 there. And at the end of the day, we're not going to send you an 11th request. That 11th request that is coming at the same time, it will go to a new container instance that we're booting up in the meanwhile. So this actually heavily informs our auto-scaling decision. And similarly, our request timeout is 60 minutes. That is one limitation that I think gRPC users need to know, because we know that a lot of you actually love streaming connections a lot. And if your connection is going over 60 minutes, that will be timed out, so you need to actually reconnect or reinitiate that connection. But there is no request response limit. Like, you can send as many bytes as you can. We talked about traffic splitting. I'm not going to spend too much time there. I think pricing is important. You only pay during requests. So if there are no requests, you're not paying during that time. And similarly, because of the concurrency, which is the ability to handle multiple requests at the same time, which if you use Lambda or Cloud Functions, you cannot really do that. Like, one instance handles one request at a time. That simplifies a lot of the application model, but it costs you more, right? So as long as you're able to handle more than one request, you're actually saving quite a lot of money here, because the overlapping requests are not separately charged. And we have a pretty good free tier, so if you want to try Cloud Run after this talk, feel free to do so. Auto-scaling, this is rather easy. We look at your HTTP requests. If there are too many requests coming to your container, we just add more instances. You can actually limit how many instances that you will have. You can say, I don't want to spend thousands of dollars. Just give me maximum 10 instances. I know what I'm doing, and we'll be able to do that. Cold starts are another question that comes up when people use Cloud Run. Cold starts do exist on Cloud Run. When let's say you have a service and you're not making any requests to it for, like, let's say 20 minutes or an hour, that container will be cleaned up. And eventually, when there's a request coming in, we actually have to wake up that container and then send the traffic to that, but that takes a while. Usually it's pretty fast. We apply a lot of optimizations to minimize the cold starts, but at the end of the day, you will have cold starts. But to prevent the cold starts, we have this feature called minimum instances. That is basically a way of keeping the instances warm. For example, if you say, hey, I know what I'm doing. My API gateway always needs 5 instances, so please keep 5 instances around. And even when you're not getting any requests, you're paying actually 10% of the normal cost that you'll be paying. So it actually sometimes becomes cheaper than a VM. So I want to talk about how are we isolating your workloads from the host. Something about Cloud Run that is, I think, really interesting is when you deploy an application to Cloud Run, it directly runs on Google's infrastructure, next to Google Maps, next to Gmail, and stuff like that. And one of the ways that we make this possible is we use something called gvisor, which is an open source system called emulation layer in the user space. And we basically run your program as inside this sandbox so that your application doesn't see other workloads and vice versa. So this might mean that some of the low-level Linux APIs might not work. For example, you cannot run Docker inside Cloud Run. But this is something that we're planning to potentially change in the future because of performance reasons, etc. So I'm approaching the end here. So if you have questions, please, I guess, feel free to write them in the chat or we'll ask. So file system and volumes, we do not support volumes currently. If you're trying to mount an external storage, that currently does not work. If you want to write files to the local disk, that counts towards your memory, so be careful there. We do not show you individual container instances. Like if you're using Kubernetes, you're probably used to seeing your individual containers there. We do not do that. We don't tell you how many containers that we're running at a time because you're not actually paying for those. You're only paying for the requests that you're creating. And if there's a faulty container, we actually try to replace that container. And if your container is crashing all the time, we try to replace that as well. And we support service-to-service communication, just like how I deployed my app without any authentication enabled to the public internet, you can actually create authentication. We do that with Cloud IAM, and as long as you can get a Google Sign token and give it to the other service using the gRPC metadata authentication header, basically, that works just fine. So we have that too. And lastly, we support imperative deployments like I just did, but we also support Kubernetes style YAMLs. And if you use Kubernetes, this will look super familiar, and that's because Cloud Run is mostly API compliant with the Knative project, which is basically using the Kubernetes pod spec. So if you notice this pod spec right here, there's a reason for that. And you can, just like kube control apply, you can use gcloud run services replace command to deploy your YAML files. So that's all I have to say about Cloud Run and gRPC. I hope you liked it. If you'd like to check out the documentation, check out cloud.run. And I have an FAQ repository that you might find useful, basically in a question and answer format. So if you have a question about Cloud Run, I probably answered it there as well. But I'm happy to take questions here as well. Thank you for listening.
Thanks for the great presentation, Amit. We have one question in the chat. Shady asked, I have a question about gRPC and Cloud Run. What happens if I have a chat app with bidirectional stream? How would that be handled in Cloud Run?
Yeah, so this is a fairly interesting point, actually. I recently wrote some best practices about how to implement the Chatroom application on Cloud Run in our documentation. I'll quickly show that as well. So that's a fairly good point. Because WebSockets connections or gRPC bidirectional streams are long-running requests, we actually bill you the whole time. Like, as long as that connection is going on, we keep CPU and memory allocated to your container, so you're actually paying for that. However, Cloud Run has pretty fine-grained billing. Like, I think we round you to the nearest 100 millisecond or something like that, so you're pretty much paying exactly what you're using. And if you're especially implementing a chat room application where, if I send a message to the chat room, all the other container instances in the fleet also need to get that message. And there are some patterns for that, such as, you might be able to, let's say, put a Redis database or something like that in the background where all the instances can connect to and pull messages to and push messages from. So you can have like that sort of pops up relationship, because normally the multiple instances in Cloud Run, as I said before, you don't get to see the instances. You don't know how many instances are running at any time. So you need a way to synchronize data between them. That's basically, that's the gist of it. Yeah. Hopefully that answers the question. Are there any other questions from the?
Yeah, if
PC
folks
here?
have other questions, you're free to unmute and ask directly. Or
I see someone raised hand. Abhishek, right?
Yeah. I probably just missed this. You described how in the Go example, the KO or Co utility kind of built the container image.
Yeah.
In the Python example, was the container image built in Cloud Build?
Exactly. So what I did in the Python example was that I used this thing called gcloud beta run deploy -- source. And I said, this is my source directory. And what gcloud does here is it packages up your container, it packages up your source directory into a zip file, sends it to Google Cloud Build. And we were looking at the Cloud Build logs here. I'll actually quickly show that again. And what's going on is I'm not running this build locally on my machine, but if you look at this particular build step, I'm actually trying to see. Yeah, OK. So I'm using this program called pack, which is the command line tool for Buildpacks. And I'm saying that, hey, just build this zip file that I just uploaded. And that build happens remotely on Google Cloud's machines, on our build farm of Google Cloud Build, essentially. And as a result, I get a container image built and pushed to Google Container Registry. And then I basically deploy that image. I get that image here, and I deploy that image as a result.
Fantastic. So this is not Python specific, right? We could use Buildpacks in this way for Java or C++ or any other language that we like?
Exactly. So the Google Cloud Buildpacks specifically support these runtimes that I've highlighted here. So if you have any application written in these things, we do support that. So basically, the angle that I'm going for here is, using Go, you can build container images out of Go programs without using Docker. And similarly, the Buildpacks helps you do that as well. Similarly, if you're using Java specifically, we have a project called Jib, if you've never heard of that before. This is also along the same lines as Go. Basically, you have a Java application and you add a few things, and using Jib, you can simply turn that application image into, Java application into a container image without using Docker. And so these three projects are basically along the same lines.
Thank you. That's super cool.
think last time I saw, if I remember correctly, I think I set up Jib for the hostname example. I think that's what I'm using to package it in the Java gRPC examples directory.
Awesome. Yeah, I didn't know that.
I might have the wrong container. There's two, and I only did it for one, but yeah.
I see.
Okay, so you mentioned cold start, and you said only when a request comes in, it activates a container, right? So what's the typical, I don't know if you mentioned, but is there like a typical like latency introduced by that?
Yeah,
Because of
absolutely.
that?
Yeah, I mean, cold starts pretty much always introduce latency, right? So to minimize the latency, something that we do is we don't download the images. We have a way of storing the images that you deploy in our own storage. That so basically, instead of the, let's say downloading the image to the disk like Kubernetes does every time, we have ways of basically pulling it from the network much faster. And by doing so, we don't have to pull the entire image. We can pull parts of the image that you're actually using during the cold starts. So even if when we combine these things, we find that most of the time, the time we spend putting up an application and bringing it to the ready state, which is basically listening on the port number, most of the time is spent in the user code. So no matter how much we optimize the infrastructure, we end up finding that if you're using, let's say, Java or C#, basically more heavyweight languages, most of the time ends up being spent in, starting your code and your code reaching to a state that when it listens on the port number. So it's primarily affected by that. As long as you can keep your application, starting up pretty quickly, like let's say a Go application, that tends to work better. Like I've seen cold start times as low as I think 2-3 seconds. Actually, while I was coding something here, I hit the cold start, and that was barely noticeable. I don't think any of you noticed that. Yeah. Yeah. Are there any other questions, or otherwise I yield the floor.
There's some questions in the chat box.
As I say, we had
sorry.
one question from Christian, but it looks like Tony jumped in and answered that. So thank you, Tony.
Okay. Yeah, perfect. Is Cloud Run comparable to Openshift? Yeah, Openshift is a much larger suite, as Tony said. I think Openshift also has its own serverless extension. I think it would be more comparable to that. That's right. Yeah. All right, perfect. I yield the floor. Thank you so much for giving this opportunity.
Sorry. I have one quick question.
Please go, Sharon. Yeah.
So in your example, right, you showed that it basically gives you a host name that is auto-generated by Cloud, right? Is there a way to actually change that to something more usable? Let's say my users always use one name and just try to that.
Yeah, absolutely. So basically, when you go to Cloud Run, there's an option up here that says Manage Custom Domains. Let's say I can create a mapping. I'll basically say that, hey, the route guide example that I just deployed, I'll say I would like to call this route guide r.ahmet.dev. That's it. As long as I can go update my DNS records to point to the CNAME, I'm good to go. Google will provision a TLS certificate for me, and I'll be able to use my domain name.
Great. And is that the host name that allows you to split traffic between two separate deployments?
Yeah. Yeah. Any domain that you will provide for Cloud Run, either the built-in domain, which I have here, or the custom domains that you provide, you'll be able to go to revisions, and you can basically click Manage Traffic. Actually, something that you can do here is you can also create, like, let's say I split traffic like 30/70, something like that. And something else that I can do is I can also give these individual revisions names. Like, let's say I would like to call this my V2 application or something like that, and then I will get this domain name prefixed with my V2. So that's also something that you can do, basically. Yeah.
Sounds good. Thank you.
Awesome. Yeah, hopefully this was a good interaction. Thanks for listening.
Yeah, thank you very much, Ahmet, for the presentation. And at this point, we've still got about 30 minutes left in the meeting. So I want to turn it over to our language maintainers and see if you have any updates you want to share. And if not, anyone on the call, if you have any questions about gRPC, now is the time, because you have the right people captive to ask your questions. And you're welcome to unmute or chat, whichever you prefer.
I have one more question for Ahmet. Yeah, you're on mute, Ahmet, so that's
Sorry,
fine.
yeah.
I'll ask my question. So is it like, I don't know if I'm right here, I don't remember correctly, but can I deploy like 2 containers together as a pod?
Yeah, that's an excellent question. We currently do not support that. So those would be either separate services, but if you want sidecar containers, the best bet you have right now is to put the 2 processes into the same container and kick it off from the entry point. Yeah.
Okay, got it. Yeah.
Thank you.
So that means this kind of environment, where you cannot have like sidecar functionality, gRPC can be very useful for proxyless kind of stuff, where last time we presented the proxyless functionality in gRPC, right? Where sidecar functionality is kind of pulled into gRPC library itself. So that can be useful there.
Yeah, potential. I actually don't know much about the proxyless stuff. Sorry.
Yeah,
well, feel free to follow up with me internally.
Yeah, sure. All right.
Has anybody got any questions about the project? Are you building something in gRPC and you've hit a wall, need some help? Have a PR or an issue that hasn't been looked at? You want to harass someone? Y'all are being way too easy on the maintainers. Give them the
I'm
hard
really
part.
happy all the PRs have been taken care of. That's great. I was
Right?
going to argue that this was a bad idea, April. Don't bring that up. But
I mean, if nobody has any questions, we can certainly have time back. But I find that very, very unusual. We almost always have really great questions that folks ask. Amit Christian's asking about copying your presentation and samples and all that.
Yeah, I'll tweet the presentation deck. I'll download it and re-upload it somewhere. But the examples that I used were basically just the route guide examples. I changed like very few things, like the port number, and added the requirements.txt file. That was basically it. Yeah, I didn't create any new examples. But yeah, feel free to ping me on Twitter. I'll hook you up with the instructions if necessary. Yeah.
I have a question. It's probably mainly focused at the Java implementation, but I'm wondering, has there been any conversation or thoughts about building a reactive streams implementation? I am aware of the Salesforce library and actually have used it quite extensively, but I was more curious about the root project.
So so you've got the sort of reactive stream stubs, which would be most of what we're talking about. We wouldn't be talking about plumbing it down into the lower levels. So we've been pretty happy with just the community dealing with those things because y'all sort of know more of what y'all would like things to look like, and y'all are more practiced with it. We've tried to provide support to make it easy to build stubs and things like that. Client calls and server calls allow you to pick little bits and pieces of the generated code without having to throw everything away. And some of the generated code you can reuse. So that's been working pretty well for us. We would say, go on more of that. If there's, some problems that, things you want it to look a little different way or something like that, that would be for y'all who know a little bit better than us. But no, so we're sort of happy with the status quo, and we would be in strong support of those other stub types. I do think Java is a little bit special here in that Java is so fragmented in the different types and styles, and it's not something that we can really, or we're not in a good position to support everything, just because we're not knowledgeable about everything. I think a lot of the other languages, there's like, if you've got a blocking API, then you just do a blocking API. There's not going to be much argument. And then some of the things that do async, like Node.js, they've got pretty common sort of patterns to go by. So it's a little bit more of a Java-specific problem, but it's more just we're quite happy with y'all to make your own stubs and stuff. If that's causing a problem, we're fine with here. But Ryan's been holding down the fort there for a while now.
Okay, I was just kind of curious. Thanks.
And also to be clear, the stubs are very, very thin layer on gRPC. So we're not really all that concerned with them causing too much trouble. It's really just a small little adapter layer. All the rest of the gRPC would stay the same. You'd still be able to use the interceptors and stuff. And so we're not too worried about fragmenting the ecosystem or things like that too much with that.
Yep. Thanks.
Just real quick, I want to call out, we've got a couple of polls in the chat question interface. If you don't mind taking a look and just leaving your feedback quickly about what you thought of today's topic and the meeting overall. And again, open for questions. Steve, you're unmuted. I wonder if that means if you have a burning question for everyone.
I do, but I'm coming from a C++ legacy project, DCOM, WCF, and now putting gRPC in it. And the async examples and tutorial have one RPC in one service. And I was just, is there any guidance there for how many threads, how many workers, tags? It's just kind of thin. So I was basically going in and looking at the source to figure out best practices, but I don't know if anybody else has been through that. Or maybe they couldn't hear me.
I was going to say, Mark's here, right?
Sorry, what was the question?
Oh, just any best practices on worker threads and thread handling for a larger than the example C++ service. I mean,
are you using the? I assume you're not using the sync API, or you wouldn't be asking the question, right? You're using the CQ-based API.
I looked at the async, but again, the example just had one service with one RPC in it, and it was like we have, multiple calls, several services.
Right, but so
how do you?
So the idea behind the CQ-based API, which I will freely admit is not a very good API, and we're trying to make our reactor-based API available, which is much easier to use. But the idea behind the CQ-based API is that it really gives the application control over how many threads you use, and the number of different calls that you have going on is really sort of orthogonal to that, because not completely orthogonal in the sense that there's still load, right? But as long as no individual RPC handler is doing any blocking operations, then it's really just, event scheduling on a set of threads, and it's just how busy are you, right? Right. It doesn't matter if it's a single RPC with a single call or multiple RPCs. It's a question of traffic, right?
Right. Yeah. It's a matter of returning it back. And okay, it's just the example is really simple. I didn't know if there was another more fleshed out example, especially using the newer async stuff with C++ 17 or
the
20.
The design really, or the problematic here is technically outside the scope of an example, because it's really up to the application writer to decide how they are going to use the load, right? The gRPC itself application is merely going to give you events. It's only going to give you, notifications about something that just happened. And then if you want, for example, to use a thread pool in order to take action upon this call, then it's up to you. If you look at, you were talking about C++, but if you look at other languages like Node.js, and I'm not even talking about gRPC JS, I'm just talking about Node.js in general. Node.js whole design is to be single-threaded completely and have all of its events being handled in a single thread, given the property that you are never going to do any sort of blocking code in the event handlers. So at this point, the example is just trying to show you how you dispatch, how you receive events and how you can dispatch them. But then if you want to dispatch them to a thread pool, for example, then sure, it's up to you. It's your prerogative. It's depending on what you are going to do. If you are not going to have any sort of computational heavy code that's going to be executed on RPCs, then you don't even need necessarily a thread pool. So for example, if you have sort of proxy server that is transferring requests from one location to another, then you don't even need thread pools at that point. You're just forwarding requests to another TCP style, data pipe, which doesn't even.
No, we have databases behind it. We have blob storage. It can be blocking.
Right.
If we don't hand it off to a thread pool.
And that's why, right? Since it's really up to how the application works, then we are, as Mark was saying, this is completely orthogonal to the principle of what gRPC is, right?
Right.
Yeah. So I mean, basically, what I would say is like it's. I would say you definitely don't want to do any blocking work in your event handler threads unless you know that you're, just going to spawn another thread every time that happens. That doesn't seem like a great, approach. I think, what I would advise is basically certainly a fairly straightforward architecture that would be, fairly simple would be, start with a fixed number of event handler threads. Those are the threads that are, pulling the CQs, and make sure that your callbacks that whatever you do when an event comes on one of those CQs is either non-blocking or is handed off to another thread, so that thread can immediately go back to polling the CQs.
Okay. So CQs are not tied to a service, potentially.
No, I mean in the CQ-based API, you actually have full control over. Like on a per call basis, you could even decide which calls are going to send their results to which CQs. Like when you create a call, you say this call will send its result on this CQ. So you could, if you wanted, and I don't recommend this, but you could, if you wanted, there are some applications that really want to tune things and, they create like different thread pools that are pulling different CQs, and then they like load balance, somehow like which calls are on which thread pools to get like prioritization of events or, whatever, right? I don't think that's a particularly good way to go, but you could do it if you wanted to. The simpler model is just have one pool of worker threads that are always polling the CQ, stick all your events on that CQ, and things sort of just work.
And then measure. Okay.
Yeah. And I mean, this will all get a lot easier once we're finally able to make the Reactor API available in open source.
Okay.
And that API is sort of around the idea of like an event loop model where you're doing only non-blocking work. If you need to do anything blocking or really expensive, you farm it off to another thread. But that's like there's plenty of event loops to choose from in C++, which is one of the problems. But it's pretty similar to if you were doing those sorts of models.
Yeah, I mean the new API will basically be, you don't have to worry about having a bunch of threads that you create that are polling CQs. Instead, you just say, okay, here's my request handler with all these methods that get called when particular events occur, and we just create a bunch of thread. We create the thread pool and do all that management for you. So it's a much simpler programming model. And so what I would advise you to do at this point, if you're writing an application, is write as if you're going to have something like that, because hopefully it won't be too long before you do. And that way you can just sort of throw out the code that you have that's actually, creating the threads and pulling the CQs, and the rest of it will basically just work.
Right. All right. That's why I was hesitant to bring it up, because all you and your fancy languages. No, I'm kidding. I've done work in .NET, but trying to graft .NET onto our legacy C++ just became more problems than it's worth. And so I was going strictly native here. All right, thanks a lot.
Sure.
Out there, appreciate it.
It's always good when Mark says you shouldn't do this, but you could.
That's
I mean,
programming.
you know, I
Yeah.
I like letting people know what they can do and what I don't recommend. Like, if you want to shoot yourself in the foot, I'll gladly point you in the right direction, but I'm going to let you know that's what's going on, you know?
And I mean, the flexibility is here for a reason as well, right? If you may have very specific needs for very complicated approaches to how you schedule your work. So yeah, even though it's not recommended because it's really for extremely specific application and usage cases. So.
Well, more to the point, it's actually not clear when we move to the new polling model how much, like, the APIs will still continue to work. It's not clear that they will actually continue to give that level of control that they do currently, right? Because, you know, they're going to be kind of the existing APIs, you know, just, you know, working on top of the new polling model, which, you know, doesn't really provide the same level of control.
Do we have an ETA on when that new stuff is coming?
Oh, there's a good question. Let's see. So,
right?
What?
Because you're not busy, right? I mean,
yeah, right. we're just sitting around twiddling our thumbs.
Right? Yeah.
Yeah. So AJ is working on. I don't know if he's here. He's probably here somewhere. Is working on a design for a new API that we're calling Event Engine, which will basically provide a way to do. I'm doing a bunch of hand waving here because we don't have anything sort of written down that we can publish externally yet. But it'll basically be an API that you can use to integrate with, you know, to basically implement the event loop, and you plug that into gRPC, and then the Reactor API just sort of works on top of that. So you can either use our provided event engine, which will be sort of a, you know, something that we ship that basically works the way it sort of does, you know, using the same underlying mechanisms that we use today of directly dealing with, you know, on Linux, you know, POSIX sockets and all that, you know, you can, you know, people in environments where they've already got some external event loop that they just want to integrate with will be able to sort of, you know, have an implementation of this API that plugs into their existing event loop. And so once we have that machinery in place, that's the key thing that will enable use of the Reactor API in OSS. And timeline-wise, I would guess, I mean, my off-the-cuff guess is it's not going to be like tomorrow, but it's not going to be next year. My guess would be within the next couple of quarters, you should start seeing something, is my off-the-cuff guess.
Okay.
Yeah, that sounds like that would be a good future meeting topic when we get to that point. So.
Indeed,
yeah, it totally sounds reasonable to me. Yeah. And yeah, excellent hand wavy description. That was way less hand wavy than mine would have been. So yeah, thank you.
I didn't want to commit us to any details before we had them, so, you know, hand wavy it is.
And again, what happens behind the event model? Yeah, it should be very easy to switch over if I need to. But again, I just need to look at, just measure and try different things. So, okay, appreciate it.
Yeah, and feel free to, you know, come back to the next meeting or send a message to the list if you run into further issues. There's always folks that are interested to help and happy to help. And I know some of the .NET gRPC folks don't often make it to this meeting because of time zone fun, but they're on the mailing list as well, so they could potentially be helpful. Anybody have any other questions or anything else you want to talk about? Anything with gRPC?
I'll just mention the releases are going out. Was it 36? 1.36? Did I have that right? Yeah, 1.36. It's published already for Java, but I'm working on the release notes and stuff, so I've not actually notified anyone. And I assume that the other languages are close behind or beating us like Go typically does.
So what you're saying is people who come to the community meeting get advanced preview of gRPC Java new release. That's what I'm hearing.
Oh yes, absolutely.
Yeah. So tell your friends. They should all.
Also, if they would be willing to work on the release notes, that'd be fabulous. No.
What? The connection's breaking up. No, just kidding.
Yeah.
Cool. All right. Well, if nobody has anything else, I will again mention, if you didn't see in the chat on the side, there's this little icon that's a triangle and a square and a circle, and that's just got a couple of quick poll questions. We'd love to get your feedback on today's meeting. Thank you for being here and joining us. We will get the recording up on the YouTube channel and share the link out on the Meetup page. And Ahmet, for your samples and all that, we'll share all the links as well there. Thank you again for the presentation.